Perry Mack and Brian Irons here with 4-Wheel Drive Magazine. And Brian, we got a little project on our hands today.
We do have a little project in our hands today. What you're seeing in front of you is a 1998 Dodge Magnum 5.9 liter. It's a very common engine. They've been building them since, I believe, about 1993 up until about 2003. I'm not sure the abuse that this engine has taken. So what we're going to do is we're going to open it up, take a look, and kind of make a judgment call as we go on how much of a rebuild it's going to need and whether it's going to suit our needs. Just so you know, our needs are, this is going to go into a 1999 Dodge Dakota, which the 4x4 versions were very difficult to get with a 5.9 liter. So we're transplanting one in there, and we're going to show you how to do that in future issues in the magazine and possibly on film as well. First step on this is to get all the stuff that we know we don't need off of it. Step one is going to be, we're going to yard off all this electrical that we possibly can. We have a complete wiring harness that's currently in the truck that this is going to go into. And the beautiful thing with this engine platform is everything plugs in the same.
The key thing here is you might not have exactly the same project as us, but what we're doing here is starting with an engine that essentially comes from a junkyard just the way you're going to get it. And so you can expect some kind of configuration like this, and this is where you can start to pull stuff off and move your project along.
So now that Perry's gone into the bathroom with the Summit Racing catalog, I guess I'm left here to start pulling this engine apart. Step one, like we said, we're going to start tearing apart the electrical, spark plugs, wiring, anything that has a connector, we're going to tear off. Any ground connections, we're going to unbolt. After that, we're going to start pulling off the front end accessories. Chances are, these are all toast. I don't know how long they've been sitting in that junkyard, and some of the fluids and some of them are smelling a little funky.
All right, so rather than take all of the individual pieces off, we've opted instead to just pull the entire front
assembly off. With these Magnum engines, their predecessor was the LA blocks, Dodge LA blocks, which date back from the mid-60s. So the blocks themselves are pretty much the same, other than the Magnum block does not have a port for a mechanical fuel pump. So a lot of the bolts in this engine, some of them are metric, some of them are SAE. So Perry and I right now are running around pulling our hair out, trying to figure out exactly what bolts we're going to need. No dead mice yet.
Yeah. So there we go with the front assembly pulled off. We're still working on that fan, and as you can see, we're using our zip locks, tagged, named, and we've pulled off all of the wiring harnesses, which is all going to end up in a recycle bin. That's it.
If anybody of you have ever fought with these type of clips, and I know you have, grab yourself one of these tools. Summit Racing sells this as well. You can remotely undo that clip and not lose your finger. I know it seems like miracle work, but look, there we go, all done. Go buy yourself one of these. Sub 30 bucks, worth every penny. So if you've ever struggled with these rubber hoses on these engines and trying to get them off, you're not going to break those off very easily. You either have to get in there with a screwdriver, or you have to try and get around here and pry it. And especially with these tin necks, chances are you're going to bend them. These hoses should be replaced anyways. They're cheap. They're easy to find. Don't worry about it. Come in, cut a slice up the hose, and then come through. You can hear it crack. Just peel it right off. As with most things we try to attempt, we have a bit of a difficult situation. So we tried to get the fan and fan clutch off of the engine and off of the water pump beforehand. It's not cooperating with us whatsoever, so instead, luckily with this design, we can get to all the bolts are on the outside of the water pump, and we're just going to take it off with our gentle persuader. Let's be gentle now. Just looking at that, that looks like it's been replaced relatively recently. Looks to be in half decent shape. And judging by the generous amounts of silicone on there, it's definitely a done at home job. we have the intake manifold bolts out. We're going to pry this thing off. We know that this intake manifold has been pulled off before, judging by the large amount of silicone bleeding out from what's called the China rail, front and back. When you go to pry this out, and you are not going to deadlift this out, I guarantee you, don't pry against another piece of aluminum. Try to go against the iron block. And we'll slowly and carefully get this intake manifold off. Oh, just like that. And, whew, that's one keg intake manifold. That's a little bit of carbon in there, so that tells me, yep, there's been a lack of oil changes. These motors, the Magnum motors, are set up for rollerized rockers and a roller cam, which is really good stuff. Makes it very easy to build lots of power, and you don't have to replace the lifters every time that you change the, if you change the camshaft. So now we're looking at the bottom side of our intake manifold that we just pulled off. You can tell a lot on these engines and how they're running, looking from just at this aspect. This cover right here, this is a known issue with these Magnum motors. This gasket that's in here tends to leak, and then you get a lot of vacuum leaks in your engine, and you get a very poor running motor. The other thing we can see here is we can actually look and see the ends of each of the injectors. And in this motor alone, we see that one's nice and clean. That one's looking pretty dirty. And on the other side, it goes from bad to worse. Here we have plenty of corrosion from the gasoline and the aluminum interacting. And I am not holding a whole lot of faith that these injectors are flowing the same rate. All right, we're ready to pull off our harmonic balancer, and we have to take this off to be able to get our mounting plate here off. So we have our proper harmonic balancer in there, bolts threaded in all the way, a 19mm, and the proper pilot bushing in there. So now we can slowly start taking this out. As you can see, there's a big chunk of steel missing here on this balancer. These motors were externally balanced. So the harmonic balancer from a 318 motor will not work on a 360. And these are keyed, so you don't have to worry about the proper orientation. You can see where the seal is ridden on there for years and years and years. You see the little bit of rust there. So we'll have to see. I can't feel a ridge there, so this might clean up with some Scotch-Brite and we'll be able to reuse it.
Oh, Brian, really?
Shut that thing off! Plan on your shop floor being a mess. Kitty litter works for picking up fluids and all that, but I've got a better product for you. Use animal house training pads. I know, it sounds funny. It'll sop it all up. You can fold it up into a ball and throw it out afterwards.
Now we're going to take off the valve covers. We're hoping that it doesn't look too bad inside. So here we go. Well, hey, look at that.
That looks pretty clean, actually.
Let's see what the other side. Cross your fingers.
Wow.
We are in luck.
Nothing bent, nothing broken.
Looking good. 2 thumbs up for valve covers.
Time to go buy a lottery ticket, right?
Right now!
Making really great progress here, tearing down this 5.9 liter 360 Magnum motor. So we've gotten to the point where we're ready to start disassembling the heads before taking the heads off. Now, yeah, you could just undo the head bolts and pull everything out as an assembly, but that has a tendency to warp heads and cause other issues. So what we're going to do is we're going to undo all our valve train components, our rocker arms here, then we can pull out our push rods and our roller lifters. Now, in a flat tappet cam, and if you were going to be reusing all these components, I would highly recommend that you separate them. Number 1 cylinder, exhaust valve, number 1 cylinder, intake valve, and put all those components together in a bag or separated somehow so that you don't get them messed up. In our case right here, we're not really concerned about it because we are not planning on using these rocker arms. We're going to get something different, and we are probably going to need different push rods, and we may even need different lifters. This engine has a rollerized camshaft in it, so that causes a few other things to happen in the valve train. If you look down here, and you can actually look, you can see the actual rollers that follow the valve train geometry. Roller camshafts were introduced in production vehicles many years ago, and they have become the mainstay. You will very seldom see a flat top tappet cam. This obviously is better because it has two rolling surfaces touching each other, not a rubbing action requiring the oil to be the lubricant that keeps them from grinding into each other. Now, with a normal central camshaft, flat tappet cam engine, these push rods turn as the engine runs. These ones do not. They've stayed stagnant like this. Now remember, this 360 base block, this basic block, has been around since the 60s, when all that was available in production engines was a flat tappet cam. So we have a few things in here. If I try to turn these push rods, I can actually feel a little groove that is worn into there, and I can feel when it sort of flops itself back into place. We can turn that all the way around. Yep, right there again. And I can feel exactly where it is. That's just on the push rods that I can turn. Many of these push rods have so many miles on them that they're stuck into place. So this is why when I say that if you plan on reusing all these components, that they should be bagged and tagged individually so they can go back exactly in the same place that they came out of.
We're pretty happy with the way things are going so far. Now we're going to take the heads off. And in order to do that, we've got some bolts to come out. We're not going to take the impact wrench onto these though. We've got 1, 2, 3, 4, 5, 6. We're just going to take a wrench on it, take it a quarter turn off. If you take an impact and start blowing your way down the line, there's a good chance that you could warp the head. And we don't want to do that because we want to hopefully reuse this part.
So we're going from the outer bolts and sort of making our way circling in, if you will. Moment of truth, Perry.
Here we go.
Let's find out. Are you ready?
I'm ready.
Seatbelt off, or if we're going to have to...
I'm still ready.
I know you're ready. Ooh, there we go. All right, let's take a look inside here. Now, initial inspection. We've got some rust happening in there, and pretty bad. So, I was told that this motor run and drove itself into its final resting place. I'm guessing that if it had run and driven into its final resting place, it didn't do it quietly. There's some factory cross-hatching in there, but not a whole lot. You saw our disaster with the engine block. Let's see if the head from that side tells us any different story. And as you can see here, the same cylinder that had a whole ton of rust in it, we've got a whole ton of rust up here. So this tells me that water has gotten in one way or another. Maybe the intake valve was left open and it rained. It does mean that this head is garbage. We will still take a better look at it. Typical of these engines is we end up getting cracks developing in between the exhaust valve. This is a Siamese engine design. So these two exhaust valves come right out our exhaust port up here. This creates a lot of heat in this area, and this is where these heads are known to crack. Going through the head gasket that we just pulled off that engine, you can see we've got some discoloration, some rotting through of the passages and everything else. This does not look the healthiest. Typically want to see them all looking like this, a nice solid piece in between the cylinder walls. This looks like we had some issues. Let's pull off the other cylinder head, see what we find. So we managed to get this side off with the head gasket staying in place, but it's not looking much better on this side. We don't have one dead cylinder, we have 4 cylinders that aren't looking so hot. I can see rust patterns along the bottom. I can see cross-hatching in the cylinder, the factory cross-hatching. Now that's a good thing. At the very end of the machining process with the cylinder block, they take what's called a ball hone and they run it through the cylinder walls. What this does is create small hatch marks on the cylinder walls at a specific angle for that engine. What this does is when that engine is first fired up for its very first time and it breathes life, this breaks in the rings properly. It wears the side of the rings so that it fits perfectly to the cylinder wall. Typically with good engine blocks, you can actually see that cross-hatching after hundreds of thousands of kilometers on them. These motors are known for that. They're known for being able to see the cross-hatching, and even if everything else in the motor is toast. That means that they're made out of good iron in the engine blocks themselves, and they did a really good job at the factory setting them up and the design of the engine as well. But as soon as you get rust, it all goes out the window. This engine is going to require at least a 10,000ths bore. And the good news keeps it coming with us on our 5.9. We now have the cylinder heads off. We did our little CSI deal on that. Now we're looking at the roller lifters that came out of this engine. Now most of them have come out and they've looked half decent. When you pull these out, you want to be able to roll them and not feel anything. Feel it nice and smooth. There's a bunch of needle bearings in there that take all the load of that camshaft going up and down however many RPM and transmit that energy up to eventually open the valve. So I pulled this one out of right here, and the issue I'm seeing here is when I go and I roll this, I noticed that if you zoom right in there, that our pin is actually rotating too. So we may be looking at a new set of lifters. All right, time to make a mess of our shop floor. Oh yeah! Oh, there's the... As a bonus, we're not seeing any oil in the antifreeze. It doesn't look like a milkshake. Here we go.
Da 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 da.
Ta-da! Woo!
Ooh.
Ooh!
Oh, wow.
Wow. If we could give you smell-o-vision right now, we wouldn't. Because this is pretty bad. That is definitely milkshake. So yeah, we had blown head gasket. There is no doubt about it. Now that we have the engine open, the other thing that we're going to look for right here is we're going to try and see if there are any marks identifying that this engine has been apart before. What we're looking for is stampings that will say, and those are just factory stampings, but stampings that would say cylinder 1, cylinder 2, cylinder 3. You can see from the factory Mopar, Dodge, Chrysler, whoever you want, they actually numbered the main bearing caps 1, 2, 3, 4, and we can guess 5 back here underneath the oil pump. So that helps us out, but it does not appear to me that anyone has actually stamped these connecting rods. So that's going to be our next step in the process, is to make sure that we have everything labeled so that we can remember which connecting rod went where. Another great place to look in the bottom of the engine to see what kind of life this thing has lived is on the oil pump pickup. Now, anything that gets into the oil that needs to be pumped through this engine has got to make it through this screen first. What is that? Oh, that's the top to an oil jug. I'm surprised we didn't have oil starvation issues with this engine. That feels like a rock, and that looks like metal shavings. It's still not a lost cause yet. Remember, a lot of those parts we weren't going to reuse anyways. But this gives us a better idea of what to expect as we continue going. So what I do with my stamps is I stamp them so that, and you can see here, when they're put back together, they form the whole number. This lets me know that it's also aligned. I have the caps on the right way, and it's got to form the complete number on there. All right, so now we're at the point where we can start blowing the bottom end of this motor apart. And really, it was quite difficult to turn over by hand. Even right now, I don't think that I could if I wanted to. So this tells me that, yes, those cylinders are, oh, what's the word? What's a PG word for canoofled? That is not what the bottom of a connecting rod should look like, let alone the top. So you can see that wear spot right in the middle where it's a coppered colored. That's because it's copper. It's actually worn through the layers of the bearing and has actually beat itself right into the copper. This motor was ready to either seize or put a window in the block, which basically means smash a rod out the side. This is not healthy whatsoever. My guess is the engine oil pressure was tanking. That should be an absolute mirror finish on that. I'm seeing a lot of little ridges in there. So I'm guessing that we're probably going to have to take our crankshaft down as well. Not great news, but This is what happens when you play in the junkyard. So we're pulling out the camshaft now. We're going nice and slow. The journal sizes on a lot of these engines go from a large journal to a smaller journal, so you can see we have some slop to help get it out. Don't be just ripping this thing out of here. We have the opportunity to actually reach up inside the engine block here, and we can help guide this camshaft out so that we're not scoring the bearings. Chances are the bearings are shot, we're going to replace them anyways, but if your plan is to keep the engine and not replace the cam bearings, my recommendation is to just take it nice and slow, and eventually you will have a camshaft out. Quick interesting note about these 5.9 and 5.2 liter Magnum engines is the camshaft isn't that different between the two of them. By upgrading to a larger camshaft or a more aggressive camshaft in the 5.9 liters, you can gain quite a bit of extra power. Just what we plan on doing. Okay, we're ready to check our crankshaft. This is our connecting rod journal and our main shaft journal. So these are supposed to be 2.125 inches across. These are supposed to be 2.81 inches across. We're going to use a set of calipers that we picked up from Summit Racing. Go through them, practice with the set beforehand because it can be a little tricky to read. We're trying to go right in the middle of where the connecting rod rode, not towards the engine, the edges. We'll pull that out here. And we are looking at 248. So we're a little bit undersized the spec. We'll have to look and see what recommended specs are to see whether or not that is within a tolerance range. Typical oil clearance, depending on what kind of an engine you are building, will be around 1 thou per inch in diameter. That's probably going to be about 2/1000ths of an inch that we want for oil clearance in between here, just so that when the oil comes into the crankshaft, it actually can go around. We don't want a super tight grip. You can see that we can turn this crankshaft. That's kind of what we want with a new motor. And why we want that extra oil clearance is these holes here. These are our oiling holes. So in this engine, the oil is pumped from the oil pump on this side through the entire engine block, and it comes through little tiny holes drilled into the crankshaft here to make sure that your connecting rods get oil. Obviously, if you look at our connecting rods, they got dirty oil. All these are going to have to get a good cleaning too before anything else happens. Just taking out the pump shaft drive gear here. These Mopar engines were kind of odd. The distributor and the oil pump gear are two different shafts, so a little bit of an oddball. Anyways, we're down to the point now where we are currently looking at what we found in the bottom end of our engine. We have all of our hot mess displayed here on our bench here. Now if we go through and we look at some of the bearings that we pulled out of the connecting rods, as you can see, there's an awful lot of damage. We've run through a couple different layers and we're right down to the copper on a lot of these bearings. That's obviously not a good sign. That means this engine had a lot of wear, a lot of miles, and probably not enough oil changes. But if we go over and we look at our main crank journals, they actually look half decent. They're all the same color. I'm not seeing any force areas. I'm not seeing where it's wiped out the shielding. And the oil grooves don't look clogged. Everything looks to be in really nice shape on these, except for when we get to number 3. Number 3 is our thrust bearing. So this is where it keeps the crankshaft in place from going too far forward or too far back. Right down in here, this is where we have problems. I can feel ridges through my glove on this bearing. So what we have here is we have a set of Michitoyo inside mics. So what we're going to do with this isn't the best way to do it, but we already know from the damage that we have here that we're going to have to open up these cylinders. There is no way that we are going to be able to run the factory piston back in this setup. Right now we want to find out, was this engine worked on before? We don't think so, but we'll find out. Now, factory engine bore for the 5.9 Magnum was 4 inches. We're going to take our spring-loaded unit here, and we're going to pick just any old cylinder. We'll go inside. We're going to try and get it as square as we can. So this right now is telling me that we are, if you can read that, 4 inches on the button. So this engine, as far as I'm concerned, has not been overbored. So now we just have to know from our machinist how much he's going to have to bore this engine out to clean up these nasty cylinder walls. So Perry, I don't think that we're going to get any offers from any NASCAR pit crew teams, but we didn't do too bad. How many hours have we spent here now? We spent 4 hours in the shop here between filming and breaking down the engine, and we learned a heck of a lot, didn't we?
You know, we did, and I think there was definitely some bad news, but on the whole, pretty much good news. I mean, you know, for the $200 for junkyard engine, transmission, transfer case, we've got a block that's solid.
Yep.
So we're going to have to bore some stuff out. I think we decided that we can use the push rods.
Yep.
Crankshaft.
Yep.
Heads.
Crankshaft, heads. We're going to send the heads off to a shop and see what they have to say about them. Obviously, the piston's got to go. Our connecting rods are fine. Depending on what we do for cylinder heads, we may be able to reuse the push rods and all the other components in there. We may upgrade them a little bit. Camshaft, we're obviously going to swap out. We found a lot of bearing damage in there, but honestly, we didn't find any bearings that were so bad that they gripped in there and spun. We didn't find any bearings that were stuck to any engine parts. Everything came apart according to plan, so really, I'm happy. We're going to ship this engine off, get it a good machining. We're going to take a good look at the cylinder heads and do some judgments. Do we want to put our money into a set of factory replacement heads? Do we want to upgrade to some higher quality iron heads? Do we want to go right out and go fandangle and go with some aluminum heads? These are all decisions that us and our pocketbook are going to have to decide in the future.
Now, you kind of glossed over the one word that I wanted to hear, and we talked about it earlier.
Pay raise?
Stroker.
Oh, yeah. So, the other option, and there are some really great kits on the market. Summit Racing sells an awesome one for this Magnum 5.9. So a stroker kit includes new crank, new connecting rods, new pistons. We needed new pistons anyways. Our crank's going to need a little cleanup anyways. And our connecting rods are going to have to get heated up and repaired as well. So, in my words of there's no replacement for displacement, why don't we put a stroker crank in it? We'll go from 360 cubic inches all the way up to 408.
And really, you've seen from the video, you can pretty much tear apart an engine with, for the most part, some basic tools. We had a couple specialty things here and there, and it's a lot of fun to do. Putting the whole thing back together, that's maybe a little bit of a different game, but getting to this stage where you can take it into the shop, that's something you can do in your garage.
You bet. Until next time.
Stay safe, and we'll see you on the trails.